So hello everyone. So today we are going to discuss the concept of don't care combinations. Okay, so you listen carefully. So these don't care combinations generally these are helpful for us to even more simplify the given expression into less number of terms. Okay, so you see the one on each and every point what I am saying here. In some designing of logic circuits, there will be some input conditions which never occur for us. Therefore, the output of the corresponding input combinations also never occurs or never appears for us. Okay, there is a condition that in some logic circuits, there will be some certain input conditions where they won't appear for us to the entire circuit operation. Therefore, the output of those particular input combinations will also never appears for us. In such conditions, there is a freedom for the user to replace either 0 or 1 according to his or her convenience. Okay, wherever the input conditions are not defined for us, in that positions you can or you have a freedom to select either 0 or 1 according to your convenience. Okay, so those output values are indicated with the letter capital X. Okay, capital X nothing but it is an don't care condition, or you can represent with a small d. Okay, when you are writing manually you can write as d, and when you are dealing with k map you should keep it with X. Okay, I don't care when you're writing in a form of expression you should write d of. Okay, how you're writing SOP summation small m of, like that. If it is don't care you should write d of something. So if you are dealing with the same concept of K map, you should replace the cells with X. Don't care cells always should carry capital letter X in that cell. Okay, you call them as don't care outputs or don't care conditions. Okay, what is don't care in the sense there is no certain rule to keep 0 or there is no certain rule to keep 1 in the cell. That cell can be, or that cell can hold either 0 or 1 according to the convenience that we have. Okay, remember that don't care condition cells are the cells which can be replaced with either 0 or 1 according to our convenience. Okay, next step. See, they will be written in this format. Suppose if it is SOP, see, summation m 1 3 7 11 15 till this it is SOP expression. Okay, till this. Suppose if don't care is to be represented, you should write as plus summation d of 0 to 4. So among the 16 cells, A, B, C, D in the sense we are having 16 cells here, 16 cell K map. So among 16 cells, 1, 3, 7, 11, 15, these cells should be replaced with 1. Why? Because it is SOP. And at 0, 2, 4 are the cells which comes under don't care category. That's why these cells should be replaced with capital X. Replaced with capital X. Okay. These cells you need to replace with the symbol capital X. Why? Because these are don't care cells. And these cells you need to replace with 1. Why? Because it is SOP. Likewise, if you say this, these cells you should replace with 0. Why? Because it is POS. And these cells 1, 3 should be replaced with X. Why? Because these are don't care conditions. Okay. This is the representation how to represent a don't care in SOP. This is the representation how to represent the don't care in POS. SOP don't care means summation D. POS don't care means pi small d. Small d is common. Only this symbol will change. Sigma here pi. Okay. Okay. So you will get a clear idea when if you solve a problem. Okay. We will take a problem here. See. See the problem. What is given? Reduce the given following expression using K-map. So here we are finding one don't care cell. Okay, same format. 3 inputs are there for us. 3 inputs are there. So obviously we need 8 cells for simplification. 3 inputs are there, so 8 cells we need. So draw an 8 cell K map. Next, assign first input for row, second 2 inputs for columns. The same scenario what we have seen previously. Now the cell numbers 1 comma 3 comma 5 should be substituted with 1. Why? Because it is SOP. So 1 comma 3 comma 5 I kept once, and the 7th cell I should keep X. Why? Because it is a don't care condition. Okay, like this I will plot. Now listen carefully. Here the cell number 7 is considered as capital X, which can be either replaced with 0 or 1. Okay, capital X in the sense, here you can replace either 0 or you can replace either 1 according to your convenience. Okay, that means you need to analyze. Suppose if I replace 0, whether this 0 is convenient for me or not. Suppose if I replace 1, if this 1 is convenient for me or not. That means for which value of 0 comma 1 if I replace here, that will be convenient for me. That is the thing. Okay, clear? Which value is to be replaced so that my simplification will become convenient for me. If I replace 0, if it is convenient, I need to check. If 1 is replaced, if it is convenient, I need to check. I need to check which value is convenient for me. That is 0 or 1. Okay. Next. Next here. What is next step? What we have to do? See. But it is important to fix that the values of the output expression consist of minimum number of terms. That means for which value of 0 or 1, I will get minimum number of terms. That is met. I need to find out. Suppose if I substitute 0, what is the answer I will get? Suppose if I substitute 1, what is the answer I will get? I need to compare the two answers. I need to opt out the term which consists of less number of terms. Okay. Okay, fine. So suppose if d of 7 is equal to 0, okay, see carefully. I will change the color to blue color. Suppose if I take 0 in the place of x, then what will be the answer? As it is SOP, I should concentrate only on ones. So I will take these two as one pair and these two as one pair. And I should not consider this value. Why? Because it is 0. So if I take d of 7 is equal to 0, I will get the answer as 2 pairs. Next. Suppose if I take x equal to 1, this value is 1. Then directly I can collect all these 4 ones as a quad. So I will get one quad. So when I observe the first case, I am getting 2 pairs in my answer. When I am observing second case, I am getting one quad is my answer. Always octet is better than quad and quad is better than a pair. Remember this sequence. Always an octet is better than a quad is better than a pair. So one quad is more better than 2 pairs. That's why I can prefer d of 7 is equal to 1. Therefore, I will get a minimized expression rather than substituting 0. Okay, how can I conclude the statement here? If I substitute d of 7 is equal to 0, then I will get 2 pairs in my answer. In the same condition, if I substitute 1 in d of 7, I will get 1 quad as my answer. Therefore, 1 quad is always better than 2 pairs. So I will prefer d of 7 is equal to 1 rather than d of 7 is equal to 0. Like that, you need to mention the explanation there. And now, what I am going to do is, I am, see, so d of 7 is equal to 1, where we get 1 quad is preferred and you need to simplify the expression. So substitute the value of x equal to 1 and then make it as a quad and write the answer as C. Only the C is the answer. Suppose if you take this condition, you will get the answer of 2 pairs. It will be somewhat longest expression. But now see, one small literal you got the answer. That's it. It is the statement we did. Okay. What is don't care? This don't care will help us to even more simplify the expression. Suppose if D of 7 is not there, you will get the answer as 2 pairs only. Suppose if this term is not there in the question, you will get the answer of these 1 comma 3 pair and 1 comma 5 pair. Because due to the presence of this D of 7, we added 1 here so that the 2 pairs is totally converted into 1 quad. Therefore, we got the answer as C. So, because of the presence of this D of 7, we got the answer as C. Otherwise, we would have got the answer of 2 pairs. So, this don't care cells helped us to even more reduce the expression, final expression. Clear? Next, we will take one more example. See here. Here we are having 4 input variables. So take a 16 cell K map, put the separators, labeling, gray code mechanism. Now, these are the cells which you need to substitute 1, 1, 3, 7, 11, 15. In these 3 positions, I kept 1. 0, 2, 4. I should keep into marks. Why? Because those are don't care combinations. 0, 2, and 4. Now, clearly you can observe this. 3, 7, 15, 11. All these are adjacent to each other so that it will become one quad. So, directly write the quad. Next, suppose as per the condition, these x can be replaced with 0 or 1. Suppose if I take this position as 1 and this position as 1, then I can directly make all these 4 ones as a quad. Yes or not? Suppose if I substitute the value of d of 0 as 1 and d of 2 as 1, then directly I can take all the 4 ones as a quad. Right? So see here, from the K map, it is clearly observed that d of 0 is equal to 1 and d of 2 equal to 1 and d of 4 equal to 0. This is the combinations where we get a minimum number of output. Okay, see, suppose if I take here 1 and here 1, then directly I can combine all these as in one pair for one quad, and I should take this as 0. If it is 0, then I no need to bother about this cell. Why? Because it is an SOP question. Suppose by chance if I take 1 here, then definitely I should make these 2 as a pair so that my expression will get somewhat increase. Okay, if I replace 1 here, definitely I should make this pair so that there will be one more adding of term in my expression, right? So instead of doing all that, so just for the small change, if I take this as 0, if I keep 0 here, then I no need to bother about this cell, right? So you should put d of 0 is equal to 1, d of 2 is equal to 1, and d of 4 is equal to 0. Under this circumstances only, you will get the less or minimized expression. Okay. Now substitute them. D of 0 is substitute 1, and d of 2 also substitute 1, and d of 4 is substitute 0. So 0 is there means we don't need to bother about this cell. So directly you take these 4 ones as a quad. Therefore, your answer will be the combination of quads, 2 quads. So the answer for the 2 quads will be A bar by B bar plus C bar D bar, and this will be your final answer. Okay, clear? So don't care conditions are the cells which help us to even more simplify the expression into minimum number of terms. And be careful. Suppose if you are keeping 0, it is helpful for you, or if it is 1, it is helpful for you. Okay. If you substitute 0, whether it is helpful for me or not. If it is substituting of 1, if it is helping for me or not, that you need to analyze carefully, and then you need to find out the final expression. Okay. By this, the concept of don't care condition is completed. Okay. I hope you understood the concept, and thank you and have a nice day.